I was working as a data engineer, and I kind of had like a little bit of exposure to it. So that was pretty cool. Kind of just like working with big data tools in like a bigger setting. Like previously, I kind of just like did some work with pandas and kind of like on smaller data sets. So it was a lot of like kind of just those kind of transformations, the stuff that could just be done on like one node, one like computer. But yeah, it's really cool to kind of like learn understand like more about how companies work with like big data. So yeah, so the kind of the goals of this workshop, yeah, so it's intended for like beginner to intermediate data scientists or data engineers. And yeah, because what kind of we're going to do is kind of learn about Apache Spark and Hadoop and kind of see like why Apache Spark is extremely powerful and like is the next version of Hadoop and like a better version of it. And then we're kind of also going to learn about the different transformation methods that you can use to transform data sets in Apache Spark. And we're going to kind of learn about more about what RDD is in Apache Spark and why like it's much more powerful and useful in machine learning, and even like the query times are a lot better. So kind of yeah, we're going to get into a little machine learning application. We can build a little machine learning model with the Spark MLlib, and then kind of the last thing is we'll finish up and we'll kind of show the application of Spark on platform as a service, Azure Databricks. So it's kind of like a new tool that a lot of people, data scientists and data engineers, are using. It kind of has a Jupyter Notebook-esque kind of feel to it, and it's pretty like straightforward, but it's very, very powerful. So we'll kind of like get into that in the later part of the session. So yeah, we'll just start off. So kind of a little bit about Hadoop versus Spark. So Hadoop kind of was the big was like an important part of big data processing in like a couple of years ago, until it's like Spark became so big. And that was because Hadoop had an actual way to break down data sets into different nodes, and it kind of would go through this MapReduce process, which I'll get into later, and kind of process from there. So it essentially like map and reduce the product, the data, and then it would process from there in those smaller, more refined sets. So kind of a little more about Hadoop. It actually has to write to the map producing process and the distributed file system before actually computing. And then because of this, it actually have to do complete batch processing data, which is a bit slower, which is actually a lot slower. And also it's like more lines of code because it's in Java, so it's less accessible to a data analyst that aren't like that technical, or because Python is used widely in like the data field or now because it's so accessible. Also the secrets and authentications while looking to try to kind of replicate your Hadoop queries and transformations on different sets of computers would be harder, because there's no well way to manage it. Usually it'd just be like a configuration file with your secrets. So it can be more like hard coded and hard to like pass around. And Apache Spark kind of solves all of these issues and makes it a lot more efficient, because it does in-memory computing, which is actually real-time data processing. And this is actually I believe 100 times faster than batch processing, or just sorry, Hadoop processing. It also is less lines of code because it's mainly written in Scala, and Scala is also the PySpark adaptation of it, which I'm probably going to be getting into in this tutorial. And then we're kind of just going to like learn more about PySpark, but it's originally built on Scala, and there's just Python adaptation, so it's very accessible. And lastly, the secrets and authentication tokens are pretty useful because it is like a token-based service, so you can pass around your authentication token and kind of get in through like that sense, if you want to like your friend wants to run your PySpark queries. So this is kind of a visualization of what Hadoop MapReduce looks like. So essentially in the beginning of it, it kind of kind of maps, and then it sorts. It does a good thing called a shuffle, and then or a shuffle or a sort, and then it essentially merges and reduces the actual data. And then you can kind of it stores in a distributed file system, so you can kind of do what you want from there. And distributed file system is essentially like a collection of nodes that data is stored on. So in like big data sets, it's not very efficient to just have all of your data stored in like one like rack, or like one like VM, or like one like computer, because like it's one huge terabyte, like terabytes of data. It can't really be stored in that if you want to process it, because it'd be very slow, because I have to go like line by line and kind of go through the whole thing. But with your Hadoop with your distributed file systems, you can actually do parallel processing of your data. So kind of will show a little example of that. This is the the phase where it actually will map. So it's like putting all of the maps of red, blue, and green. So it's kind of just mapping right there. And then the second part is the shuffling phase, where it actually like sorts all of like the like terms, but like they have like similar key values or like are the same key values. And yeah, kind of in the map reduce phase, it like essentially gives a key to each. So in this case, it gives like a key to each set of data. So as you can see, like the reds all have like one key, and then the blues have like one key, and the greens have one key. So in the shuffle phase, they can just be sorted by their keys. And then from here, this is a sum function. You can say like, okay, you can add all of these piece of the node or piece of data in each node, and it's really easy because they're all the same. So it's like you can kind of build off of cache memory computing. Cache memory is just, when something is stored of like the same the same like term or is actually been done before, you can kind of reference that cache before and not have to compute again because you already know the answer to that. So that you can just kind of use the cache here, and that's kind of what they're like from a high level, that's like kind of what they're doing right here. So Spark is a bit different because Spark actually already distributes your data before on kind of, I'll talk about like the whole data structure application of it after, but like the way it works is it essentially has one driver node and a bunch of worker nodes, and this is called a RDD, a resilient distributed data set. And essentially what the driver does is it sends out instructions to all the worker nodes and essentially creates like a workflow for each of the nodes to work in. So when it creates this workflow, it basically assesses like the most efficient and the fastest way using like the least amount of processing power to actually make your data. And this is actually like a lot faster because instead of mapping it down to like like the keys, it will already have like found a more efficient way to process. So this is kind of visualized in like a DAG sense, and a DAG is basically called a distribute, or it's a directed acyclic graph. And kind of the difference between a directed acyclic graph and a regular graph is it's first, it has no cycles in it, and it's like directed one. So it's all like kind of one arrow is kind of friendly down to one final point. So as you can see, like if you guys have taken data structures before, you have your undirected graph, and then you have your cyclic graph. There's basically like a cycle. And then you have your directed graph, which kind of just goes to like, it has edges that like point in one direction. And or like each node has like a point, this point to like the next node, where as like in a DAG, they do that, except there's no cycle. So as you can see, like directed graph, there can be cycles. So this is kind of used to create a workflow that kind of puts like does each processing in like one place, and then it kind of knows, okay, I'm gonna start from here, and I'm gonna go to this next node, and I'm gonna start from there. So kind of just a visualization of this is in like, if for example, when you're parallelizing your data set, that's so the parallelize function basically sets up each like worker node with parts of the data set. So when you're parallelizing, you're first gonna do the parallelize, and it's gonna filter, which filtering just like kind of making it more like kind of going through and kind of filling your query, and then it's going to map it. And then what it's going to do, once it maps it, essentially makes a new RDD, and a new RDD it just needs a new stage for it. So it's going to go to the next stage, and it's going to do so your next key thing is called reduce by key. If you whatever, like this is the function that you might want to call. So it's essentially going to go from here and then map it again, and then go to this stage because it's like a new RDD. But then you say, like, let's say in your join function, you want to join stage 2, the RDD in stage 2 and the RDD in stage 3, you can join them. And that will basically call the RDD from here and RDD from here that you just made from that. So you're 2 from here. So as you can see, like it's essentially one cycle of sorry, 0 cycles, just one direction and one like process. So this is called a directed acyclic graph. And it basically goes in one direction. So everything kind of ends. There's like a head stage and there's like a tail stage. It just goes in one direction, and there's a bunch of like little sub directions I can go in. So they can go in this one right here, and I don't know if you can see my mouse, but okay. Let me just see if you can get my pointer. Yeah, so kind of it just goes from this stage to this stage, and also goes from this stage to this stage. So it's like your kind of branches out, and then in your final like join stage or something, or like your show phase, it'll kind of show them all or join them right here. So I'll kind of get into like kind of I'll show you the Spark UI later, and kind of it'll be more it'd be more interesting to kind of see how it works, because I feel like this might be kind of confusing to some. And then yeah, so this is kind of just a visualization of like how Spark works. So for example, this is just saying that like this is a txt file that just got used as you do Spark context, and then you're entering text file, and then your parameter is like a text file. So what you're doing is essentially it's like creating this RDD, like it's creating like two RDDs, and no, sorry, in this RDD there's like two partitions. So the first partition is like the Artivore, and by the second one's like by Sun Tzu, and then you kind of your map thing, because kind of Spark only has two methods, that's map and reduce, or map and filter. So essentially what you're doing is you're just mapping it. You're creating a new map that adds everything to lowercase. So you're partitioning these two, and it basically goes in a partition, it partitions and then filters out like the one that you want it to be. So that's what it does, like kind of right here. And then because every map, every like transformation essentially is like a new map to your existing data set. So you're essentially like you keep on creating, like imagine like a tree, I guess. I guess this kind of shows it like it's like a tree, and like a binary tree or something. It keeps like going out, and then like the latest transformation is like the child nodes or something, or like the leaf nodes, I mean, like that's like your latest transformation. So like that's kind of what it does here. And the flat map is essentially negating the map, because it actually doesn't map anything anymore, just kind of prints out everything. So this is kind of like, just imagine if every every like thing just kind of outputted, like they weren't like all everything was related, like there's no really relation between all these, they're all just whatever is like the current right now. So that's what it does right here. And then in the filter, it essentially, yeah, like pretty straightforward, like it filters every size that's greater. It only filters the size that are greater than 2. So everything that out is less than 2, it'll filter it out. And that's kind of like the reduce part of it. So Spark does still use like the mapper, it still has map reduce, but it kind of is used like after, and it's used in a more efficient way than Hadoop, where it uses like immediately. So that's kind of what it does. Yeah, so this is like kind of the end of the presentation right now. And we're kind of going to jump into the Jupyter notebook. So let me just do that. Okay, and then just restart. Okay, so yeah, so we're just going to kind of show you how to create an RDD in Spark, and then I'll show you like the multiple ways. So first we're just gonna I believe this already be here, but we're just gonna install, yeah, dependencies already there. Just PySpark, which PySpark is the Python adaptation of Spark. And then we're just gonna put in the libraries. And then so what I try to do here is I try to like show the Spark UI using this thing called ngrok. And yeah, it works. So we're just gonna, I'll show you the Spark UI when we go to Databricks. But essentially that's like what you do for here. And then okay, so when you're creating the RDD, you want to set up your Spark context. And then you kind of just put in your Spark session SQL context. We're gonna get into SQL later and how you can use SQL with Spark. And then this is kind of showing well, yeah, this is your Spark right here. So this is like it's showing like the location that we're at right now. So what we're just gonna import this file. I'm just gonna make a simple like API request and just take this in and store it locally. It should be stored locally. Yeah, so it's stored locally right here. And then yeah, so this data set is like a data set used from like a data mining tools competition, where they were kind of just seeing like where like is a network interaction a attack, or is it like a normal, and then they were making like a model that could do that. So this is like a data set from that. And then yeah, so we're just gonna kind of put that in like a Spark RDD. So this is like creating an RDD, and then we can just see how many entries are in this data set. Yeah, so as you can see, this is right there. And then yeah, we'll just take 5. So these like the top 5 like entries in these things. So yeah, like this is kind of just like Spark context to see how many like your first 5 entries, because the thing is you don't really want to show you never want to display all of your entries on like your main node, because that like basically will overwhelm it. Because the thing is like in this like code here, so imagine like we're working in like the driver node. Like obviously I'm not like running on like a cluster of like computers right now, because like I'm just using my laptop in like a Jupyter notebook or Google Colab, I mean. So the thing is you never want to show all of like the data from all the nodes on one node, because that's basically like going backwards and like overwhelming one node, even though we want to like distribute it distribute it immediately and then work from there. So That's why, if you just want to see a preview, you can use your take. And this is kind of like just shows your your first size. You can, if I did like 25, I could do the first 25 entries, but yeah, we're just showing the first 5 entries of our data set. So yeah, then the other way to make it, so this is making it from a file, and the other way is you can use a parallelize. So we're just gonna create this list right here. And then you can just show like this is the length of our list. So this is like this many entries. And then we're going to parallelize these. So what we're doing right here is we're basically turning this data set that we made right here. So this is just like a dummy data set because there's no real values. It's just like a list of numbers, but like a vertical column, like think it's a column of numbers. But what we're doing is we're like parallelizing them, and we're actually turning each. So what it's doing is making 4 RDDs. So as you can see, when this is parallel collection RDD 4 is basically making 4 RDDs. Or sorry, in our collection of RDDs is making four partitions, right? So just imagine that like you have your you have your cluster of like computers, and each computer, you have 4 computers, or you have 5 computers because you have your driver node, and in each computer you have one of these partitions, and then you have your driver node which you're coding from, because the driver node always has the code base, or like the code, and it's basically turning that code into actual like physical actions for the computers to take. So that's what we're doing, and then we're just going to do the collect functions. This is just showing this is like kind of dangerous because it's not like a huge data set, but it's just collecting like a break set. Like I think Python will only show like X amount of value, so or a Colab will. So it's kind of like bounded, but this is like if you want to show your whole data set, you just do the collect. But again, like you never want to do that. And then yeah, so since we set up our RDDs now, we're going to be getting into the basic method. So we're going to have the map and filter method. So first we're kind of going to the map method, and if you can kind of see here, so we're just going to take this take the 5 from our nums RDD, and then we're going to pass in this function, this lambda function right here, this map function. So what this does is pretty straightforward. Like it basically just squares everything. So so what it's doing is it's going to map all of these numbers right here to squared numbers. So it's going to create like a new RDD that has only square numbers in. So essentially, like think about it, we're going from our last node to like our new node. As you can see right here, we're going from this stage right here to this stage because we're mapping. So we're going to like a new stage because we're making like a transformation. So it's making like a new RDD, and this is like our latest RDD, right? So we're just gonna make that right here. And then if you want to like take 5 to show like it's squared, right? So this like basically these two are like completely different RDDs, right? Like these are but like they flow into each other. So like they're related, but it's like only related in like a one-way stream because of like how we saw right here, right? Yeah, so we're gonna do that, and then also then we're just going to make something where we're going to make like a key for our map so we can kind of group them later. And what we're going to do is we're just going to make group them by the number of values in the actual number. So if like in Python, if you convert something to like a string, then you take the length of that, you can see how many like digits are in there. So we're just going to make that, and then we're just going to take the first 25. So as you can see, like the key is the number of digits in the number, and then the number of it, it's just like from 1 to here. So and then what we're going to do is we're only going to take the filter. We're going to show the filter function. So the filter function, so like this one, all just added transformations to it, and actually just let like it did transformations to all the data, right? Because we're leaving all the data there. But now what this filter does is it filters out data that does not align with filter. So if it does not equal 0, which is this like a mod 2, so anything mod 2, if it mod 2 equals 0, that means that it's even, and if it equals 1, that means it's odd. So so as you can see, we're only going to get the even numbers out of this, or like so as you can see, we're taking from the 1th column. So this is 0th column, and that's the 1th column. And then we're only going to take out numbers that have an even number of digits, right? So so even number of digits, then we're just going to take the top 5. So we just made these pairs right here, and then we only have two digit numbers and above, because see like these 1-digit numbers, they only have one, so they're all going to get filtered out in the map function, or in the filter function. So now what we're going to do is we're going to add like another transformation where we're going to basically flip them. So we're going to say like, okay, this 2 is going to go in the front, and then this 10 is going to go in the back, and then I'm just going to do for all of them. Because again, map does transformation to all of them. It doesn't take any away, only filter takes away. So yeah, now we're just going to show how like I flip them. And then, yeah, so now we're going to group them. So now what we're going to do is we're going to create a new RDD called grouped, and grouped is now partitioning each data by a key. So now we're going to make a, now these are all going to group by like one key. So, like in cases that they may be the same, they may be like two numbers of the same value. When Spark is doing its computation, it can see that, okay, maybe I already saw that the product of these two numbers is like this. So I don't need to do this process again. I can just refer to this cache right here and give that as the answer. So, in kind of your lead code and your interview prep, you might be doing that. With like two-sum, you need like a hash map that stores your answers that you've already like had, so you can see which one is like the sum of the two. So that's kind of what we're doing here, but it's kind of in a bigger like data setting. So kind of see like there's, I guess there's a little parallel there. So now we're going to just take the top two of these groups. So these are two new pieces of our RDD, right? So these are like we just broke it down, and now we have two more pieces. So that's basically what we do. These groups, this is like all the ones that have 2 in the key and all the ones that have 4 in the key. So these ones have 2, so they're all going to be in here. And now what we're going to do is we're going to actually apply a transformation to this. So we're going to basically list, right, like a list of whatever is in this. So we're basically expand this right here. So as you can see, like this is for the 4 ones, right? Sorry. Yeah, so these are the 2s, and then we saw the 4s down there. Yeah, you saw the 2s and the 4s. So there's just like kind of transformations to a whole like partition in a RDD. And yeah, now we're just gonna kind of find the average of like each thing. So as you can see, like this is our keys, 2, 4, 6. They're all even keys, and then just averaging everything in the data. So this is very very basic transformations, but like actually like data scientists, data engineers will put in like very complex functions to these transformations. They might even not use lambda functions. We're using lambda functions because they're very simple, like they're one-liner functions, like very Pythonic thing that we can just teach and like learn with. But they might be putting like huge, like heavy functions and passing them in as parameters. So we're going to do that later in our machine learning application, but this is kind of just how it works like that. And then, yeah, so we're just going to kind of get into the SQL part of this. So just 1 second. Okay, so yeah, so what we're gonna do for the SQL part of this, so we're just gonna just create our data frame right here, and then kind of just making like our new table. And then what we're gonna do is we're gonna like dump our data into this new temp table, and temp table can be used to actually make SQL queries from. So as you can see, there's like a SQL query right here. So you like this select from where, and then they're all like pretty common SQL statements. So you can see you could just pass this in. And the thing is, like, people that have used like pgadmin or like psychopg, they've actually they actually need like a cursor for their database. But right here we don't really need to do cursor because like Python or Spark has like a built-in cursor for this. So we can just do the SQL query right here. Just like I'll show you like how this works. And yeah, so it's basically like a simple SQL query. And in our later Databricks, when we get into that, we're going to show how like you can actually use Spark to make a SQL query from like a NoSQL database. So which is like really cool, which is really like game changing for a lot of people, both in like dev and data people. So and then yeah, this is kind of like just more SQL queries, just showing like how it works. And then this is basically just like, yeah, so this is showing like the duration of again, like for our context of our data. And then essentially we're just going to show the schema right here because if we have to register the schema. So this is kind of just showing our schema right here of our data. And then yeah, just like showing another way to do SQL queries. So like there's multiple ways. There's one you can actually type it out, but then this one you can just do the SQL and then just do like this. So you can just group by like that instead of actually like having to do like a full SQL statement right there. So and you can see like the query time is pretty fast as well. So but like this is like obviously this is not like the best way to show off Spark because I'm doing on like a one node, but obviously if I was doing on like collection of clusters, or like a cluster, sorry, with a collection of nodes, or node, like nodes are basically computers. So if I did a collection of nodes, it'd be a lot faster. So yeah, I'm just showing like more queries. Just yeah, so this is also showing how I can, I can put this into this get label type and label the data and then put it in like this. So you're just dumping this in to like a new data frame, just dumping like up this function. So based off this. So that's what we're doing here. And then yeah, we're just showing like the amount of normal and attacks that, like, again, for this for the context of this other thing. So yeah, we're kind of just gonna skip this because I think we should jump into the machine learning application of this. So yeah, so this is like really cool that Spark has this machine learning library, which is very important for like many data scientists to use. So what we're gonna do is we're gonna try to actually make a classification tree that will predict if a network attack is a normal interaction or like an attacking interaction. So as you can see, like we have this data up here, and we can see that there's normal attacks. We want to predict, okay, is the next one going to be like a normal or attack based on like the interactions, like kind of the spike of traffic within that network. So we kind of want to we want to have a model predict that. So the first thing we're gonna do, we're just gonna kind of load in this data and actually make our like initial like splits. Yeah, and then splitting the data set is made so that we can kind of see if we like where we want to partition it by. So right now we're going to partition it by our we have our clean line splits, and what we're going to do is we're going to ensure that like when we're putting in our testing data, because this is our this is our training data right here, and we're going to label our training data, but we want to make sure that what like points that we put in our training data are not in the testing, or not in the testing set, because when we actually test our model, we want to make sure that the model is like completely unknown to like what's gonna expect in the testing set. So it's like a completely controlled environment for the model. So we want to make sure that like there's no data points that are in. So that's why we have our try and except statements, because if we see that it's in it, then it's not going to put it in, and the opposite, it will. So that's what we're gonna do right here. And now we need to actually train the classifier. So while training this classifier, this like model right here, we want to make sure that we're actually going to use a smaller depth. And like basically, like if off a like it's like a binary search tree or something, like the greater like the depth is for the node depth, like from the root, it's going to have like many more leaves, right? And like more leaves in this instance or use case is like basically more decisions, and more decisions basically means like more action, because the model has more paths to go to see where it's going to if it's going to like choose this path or that path. So it's going to have a lot more decisions, and if it has more decisions, it's going to be more accurate. But in this case, for interpretation, like learning purposes, we're going to keep the depth like pretty small. So we're going to make it 4, and then I'll show you about like why we're doing that later, but we're just going to train it right now. And then yeah, so just wait for that. Okay, so now we trained it, and kind of we have our model ready, so we can kind of just show, just we can evaluate it, and then we can like test the accuracy of it. So this can take a while again, but yeah, this is basically, so after on the data that we trained it in, based off this data, we're based on this training set, then basically we just trained it right now, and then now what we're going to do here is actually test it with so we're going to test it against the test data set and see how accurate it is. So we're going to see like the amount of times that it had a proper like a real count, and the amount of time that it didn't have a good count. So yeah, so as you can see, the accuracy is like pretty high, because it was from the same data set. So like we did essentially what we did was we took training points and testing points from the same data set, but the machine learning model was completely unaware of like the actual training data, but it had points that were very similar. That's why the accuracy is very high. So now if you want to just show like what the okay, I don't know what that should be. Oh, sorry. Yeah, so this is kind of what our tree looks like. So if you can imagine this like just vertically as like a tree, it has a ton of like if statements, right? There's other on us. That means like these are all like children of these ones, right? So if you can just imagine like a massive like binary tree, except instead of instead of like like a binary search tree or something, it actually has like it's like a decision tree. So it has like okay, yes or no, yes or no. It's like it is a binary tree. So it has like it has either get like a yes or no options, and it has all these like else if and if statements in it to like predict what like the outcome of it that or the outcome of the set will be based on like the data that is given. So like this is all made, this is all trained to like have these kind of logic statements based on the training data that we gave it. Yeah, so now we're actually going to build up this model, and we're going to make a test set for it, and then we're just going to train it with this other like with this new training set that we made, which is more with only gonna have the three main variables. This one is kind of like more general, but we're making a more specific one this time. And then yeah, so we're just going to test it now. And yeah, so it's yeah, we're only going to use these main points to just make it more more applicable to our use case. Okay. So as you can see, like the actors per tab, because again, it's taken from the same set, but this is like kind of what you like in a production setting you'd want to kind of take. You kind of want to test the model against like other data points that are like outside the environment. But in this case, kind of we in this like this competition or something, they were using like this set, and they're also training from this exact set. So that's kind of what we mean, and that's why our accuracy is pretty high. So yeah, that's kind of building like a machine learning model in Spark ML Lib. And now we're going to kind of get into the last leg of our workshop, which is going to be kind of the Databricks application of Spark. So yeah, so I'm just going to kind of go into my Databricks cluster. So okay, so I believe it should be offline, yeah, because my thing is all kind of just, so this is gonna take like a while to warm up. So I'm just gonna start this. It should begin. Yeah, so it's starting to warm up. So what it's doing right now is allocating VM instances that it can use for its cluster. Yeah, because it's like in the cloud, so it has to allocate the instances before it can actually like make the cluster. And because it's a cluster of worker nodes, it's gonna have to look for like a bunch of different VMs that are also in the same availability region, so that they can work like in parallel. And just because so there won't be a lot of latency when you're actually sending out the information from like the driver node. So as you can see, when making this cluster, you can create your worker and driver type. So I'm not using like a massive data set. So I just need like max 8 workers max, and then like minimum 2 workers, just kind of show how Spark works with like workers and drivers. And then you can kind of like customize your workers to like have how many like cores or how many memory, how many gigabytes memory it has. And then you can see if we want to like differentiate from the driver type. So if I'm using like a way like more data intensive set, or like a way more like compute intensive set, I'd want to use like workers that are like way more powerful than this. So this kind of like your standard and like your basic, but that's what I'm kind of doing right here. And also kind of a downside to Azure Databricks is that if you actually like want to use it for like your project or something, you actually will have to buy an Azure subscription, which is like on the pricier side, because in the Azure free tier they only let you use I think 4 cores. And as you can see, like you're using like a minimum, you have to use a minimum of like 2 workers, and like 1 worker is already 4 cores. So you're already like maxing out your compute limits with like 1 worker. So it's a very big like kind of thing to use. But Databricks is like really cool to kind of do your analysis and like building models upon, because of its it's like scalability and easyability, because you just I just kind of went to my computer, I said, okay, spin up the cluster, and that's what's just allocating all the VM instances right now. So this is like kind of in the more cloud, the cloud domain. This is called like platform as a service, because I'm basically sending my code in, and it's basically doing the rest from that. So it's like already allocating the VM instances, already like making them. I'm just kind of giving the very high level how many gives of memory or how many cores I want. I'm not saying like, okay, where do I want the or I said where I want the cluster to be, and I said it was like going to be US East, but I'm not saying like, okay, I want this kind of like CPU or I want this kind of GPU on my computer. So like that'd be more like infrastructure as a service. So this is called platform as a service. So yeah, as we're spinning up, any questions about like cloud or like how like any cloud use cases? Okay, cool. So yeah, so our cluster is ready. So now we're just going to go into our notebook. Okay, another question. Okay, cool. Yes, we're going to this our workshop notebook, and then we're going to attach our cluster to the notebook. And then we're just going to run this command right here. And then, okay, so this is kind of before I get into the other data set that I'm going to be going forward with. I wanted to just kind of show more about how the director acrylic graphs work, or director acyclic graphs work in Spark, kind of like give like a better like data structure overview to Spark. So I'm just going to run this right here. And this is essentially, so I'm making these data sets like 100 million. And then like I'm making these two data sets that have 100 million rows in them. And then I'm going to repartition them to like 9. And then I'm going to do like a select on these, kind of just like by ID, like grouping them by ID. And then I'm going to try to join them on the ID. Because you know how I can like an inner join. This is basically like an inner join right here. And then I'm going to like select the specific ID, or and then I'm going to finally like show this thumb. So it's a pretty like long task, because I'm basically using a lot of I'm using a lot of worker nodes for like kind of no reason, but I just want to kind of show how it works. So like with the Spark UI. So yeah, so now we had output, and then we can kind of review the stages right here. So the first stage, what it does is it does this whole state code gen, and then it exchanges, because like this is basically like making the state of the RDD. So this is an RDD right here, and then I'm exchanging it. So I'm kind of just like pushing it. And then what it's going to do here in job 1 is it basically runs this as well. So essentially like these two jobs are running in parallel. That's why like they run at the same time, as you can see. So like in the event timeline, or I don't show this one, the for job 1, but essentially like you will see in job 2 that it act like these two actually run in parallel. So I'll go to job 2. And as you can see, it skips these 2 stages, because basically only one of these tasks are given for each node. So once the node is done with it, it's going to like say, okay, I'm done with this, and it's going to pass it on. And then it's going to like take the next, it's going to take the next like available, it's going to take the next available state. So what it does, like the first worker like does this task, and then it says, okay, I'm available, and the second worker does this task and it says I'm available, and then like just one of them, whichever is like ready, takes this bigger job. And essentially what this job does right here is this is our joining right here. So what it's going to do is each time we're repartitioning, we're making a new thing, it's going to make like a new DAG, right? So here we need to repartition this data set. So it's going to like flow into this node right here. And then this one's also going to flow in this node. And then this is kind of like this is like a simplified function. Usually like it should go into like another state, but the newer version of PySpark kind of allows for this. And then what's going to do is going to sort and sort everything by keys. And then what's going to do is going to combine them by their keys and like basically make the join, and then set that as the new state, right? And then for the last state, what it's going to do, it's going to skip all this because it's all been completed. Can I drag this up? Okay, so yeah, I don't know why I can't okay. I can't really like, I don't know why I can't like scroll over there, but essentially what it does is that kind of the same thing where it like just has a repartition, because I'm making a show, so it makes like a new a DAG, or make a new RDD just to show it. So yeah, as you can see, like it's kind of like a system of processes that work out. And essentially like what happens is in the beginning, like right before the Spark query is made, or the what like this is all these processes are done, the driver nodes, like our code node right here that we're working on, we're working on driver node right here. So what a driver node does is it essentially has logic in it to make the most efficient DAG path. So this is like a DAG that already created before actually like sending it out. And it knows that, okay, I'm gonna like process these two in parallel, then I'm gonna send this to here and then process these like in one stage right here instead of making two stages, and then kind of send in a third stage. So it's like very, very like quick, even like usually in like an older version or even Hadoop, it would take like a lot longer. But since you know, it kind of allows for that already, and it makes the most efficient path, it is very quick. So yeah, that's just kind of about that, kind of showing how like Spark kind of works. And then I kind of wanted to add a couple of notes on like why a Spark needs a DAG. So essentially like it already determines like the kind of preferred location that each task should run on. You know, can kind of see, okay, this worker node has like this, these pieces of data in it, and this query right here is only querying from this data. So instead of like querying the whole set, I'm only going to query this node and then return the results for that node. So as you can see, like it's pretty like quick with that, and it's pretty efficient. And like it has like a lot of logic in it to ensure, okay, we want to use like as less processing power as possible and be as efficient as possible. So yeah, so we're kind of going to go into our use case of it. So for this one, what I did is I set up a Mongo Atlas DB. And yeah, this is all like a NoSQL database, right? Like a NoSQL database is essentially like not tabular. It's like a bunch of JSON files. And you know, in like your tabular SQL database, it's all in columns, but this is like it has no columns, it just has a bunch of JSON files. But however, like we'll still learn how to query this because Spark is really powerful like that. So more like this is kind of like my secret right here, how I can connect to the database, but I'm just gonna build out this database right now. Oh, sorry, I'm gonna start real quick. Okay, yeah. So as you can see, it's like very like kind of Jupyter notebook-esque, where you like run each cell by themselves. And then yeah, so now we have our data frame, and you'll see this, as you can see, like it used the tree aggregate. So the tree aggregate is kind of again, it's like kind of like a tree where so it's sending instructions to one node, and then they send instructions to their worker nodes, and they send instructions to their worker nodes, and it kind of just flows down like that. It does this because it's connecting with the MongoDB right here. So it has like a lot more instructions to send out. Oh, also I forgot to tell you, kind of just going back in the compute and processing. Okay. For my libraries, I kind of have these libraries installed just to like kind of connect with the MongoDB. And then also this is just like an XML file handler because there's some XML files in like my Databricks. But essentially, like also what Spark or Databricks allows for is you can actually pull in a bunch of different data, like even NoSQL and SQL data, or sorry, NoSQL and tabular SQL data, and actually combine them in like a data lake. So that's like a really like important thing in you know, the data world, because you have a lot of like data that's in different shapes and forms, and combining it is huge because you can kind of combine all the data together and do analysis on all of them at once, or like, you know, make them all for like one training set at once. Whereas before you do your all your analysis in like your NoSQL environments or your like Cassandra databases, and then you would have to do all your computing in your SQL Server databases, and then kind of have your two little analytic boxes at the bottom, and that kind of would be inefficient because you don't know like the relation between those two pieces of data, even though like they may be like very connected, but they were just collected in different forms. So the data lake in Databricks allows for the data lake is like very, very important, and it's very like powerful. So yeah, so we'll kind of show like what the schema looks like. Yeah, so this is what the schema looks like in like our thing. So as you can see, like it's like a ton of different like sub categories for this data. And as you can see, if we kind of go back to here, it's like it opens up into like a lot of things. So yeah, it's kind of just showing like the schema of this. And then yeah, then we can do it like we can show. Then this basically is like very cool, because what this just did is, so we created our temp table right here. Okay, I don't know. Yeah, so oh, sorry. So we haven't created a temp table yet, but what we're doing is, what Spark did for us is it essentially put this SQL data in a tabular database and grouped it based on its like most high level thing on it. So you can see like this thing, ID, configuration, CVs, impact. So you can see like, or we can just look in our schema, you know, like the highest level things is what it's grouped as, like ID configurations, or sorry, ID, and then yeah, configuration CVEs, like the most high level impact. It's all like kind of grouped by that. And then you can kind of, if you want to go into that deeper, we're gonna kind of get into that later, like right now. But that's basically like really cool that it like converts it to like a SQL and or a SQL tabular environment. And then yeah, we're gonna make a temp view of this. And then we're just gonna like do like a simple SQL statement, which is like cool because Spark like allows for that. So just gonna run that, and we can also like view the we can view like the jobs on this. So you see like it does this all, and then Exchange is basically like shuffling. So it shuffles based on keys. So it essentially maps, and then it maps the partitions. Then it does this is kind of just the processing stage, and then it exchanges, which like shuffles and groups everything together. And then we'll do a final thing. It will like, oh yeah, the shuffle query stage, which like is when the query comes in, and then which sees that it's a count. So then it's just going to do the count processing and then output the count. So as you can see, right, it has like a system of directed movements that it should do, and like the driver node makes that and sees, okay, this is the most efficient thing that I'm gonna the most efficient way to process this and process this query. So I'm gonna go like this. So that was the way for that. And then yeah, just like another query, just you can say like you can take your sub parts, your OID. So if you go back to the schema, you have your ID and then OID. So just like your sub parts of your like your sub labels, you can add that. And then if we can just do let's do like a group by right here, which we might want to see, okay, like which is like the most amount of base scores if we added them all up in like a specific environment. So like just to see like how in this data set that we're given, like what is like the majority, and then you can kind of visualize it right here, very easy, like plot. And you can see, okay, wow, it's like medium is like the most, if you added up all the medium based scores, that's like a lot more than like the high and the lows in like, so we can see like there's been medium vulnerability attacks to these web pages. Yeah, so that's kind of it for our like kind of intro to like Spark and like Databricks, and learning about like big data processing. So and I'll kind of like we'll open up to you guys if you guys have any questions. I feel free to answer. So yeah. Does like anyone want to have any questions about any of the technologies or like terminologies that we use today? I'd be happy to answer. Okay, I guess there's no questions today. Yeah, so I think that kind of like wraps up the workshop. Oh, sorry, you got two. Oh yeah. Oh, thanks thanks so much. I'm glad everybody enjoyed it. But yeah, like if you have any questions, you can just like reach me on LinkedIn, or you can just message me on my email, which is dpark@uwaterloo.ca. Yeah, so thank you all for coming, and like I hope everybody has a great rest of the day. So yeah, take it easy.